Good morning, Mr. Fitzgerald. How are you doing today?
Good, thanks. How are you, Isaiah?
Pretty good. Just got to take care of a dog and do school at the same time. So
Oh, no.
it's a little bit of a
That's not an easy thing, yeah.
struggle. Are they still doing the in-person after school, like the small groups of people who need help after school? I was just wondering.
They are well, they're doing it, yeah, either Tuesday, Thursday, or Monday, Wednesday, but you have to already be signed up for it, though, to do it. I think they're going to expand that, though, going forward here in another week or so.
Yeah, because I know they're gonna try to do the s'mores start or whatever that is.
Yeah.
I don't even know. They gave like a little like text message video thing. It was like linked to a video, but it didn't really explain anything.
Yeah, they're kind of short on details of all that stuff right now, just because, once again, the state's changing the rules of, what's allowed and what's not. So it's a little confusing right now. But my understanding is that next week or the week after, they're going to open up that in-person learning to some more students until the end of the semester. So
Yeah, that's good. And then they're probably going to try for second semester to get it to be able to do in person if they can.
See, yeah, the state won't actually have any sort of finite guidance on that until the 19th of this month, and so and then everybody's going to have to figure out how to implement it. So I don't know. I'm not sure. That's my guess, is that they're going to try to do it for next semester, but I don't know anything.
Yeah, a couple schools have gone back. I know Salem Academy is going back next week, and Regis is going to try to go back second semester as well.
Yeah.
But they just don't know enough at the moment. I don't know how Academy's going back next week.
I heard that the Lake Oswego School District was going to start bringing people back soon, next week or the week after that.
Yeah, I don't know how they're doing it though, because there's not too much information out right now, and then they would have to how much time they planned before this.
Yeah. I'm still waiting on some people, so I'll give it another minute or so. Those people. We're missing Cameron, Smith, Chance, Lucas, and let's see, Elliot. Okay. All right. So how's everybody doing in general and math-wise, and is this stuff making sense? Starting to get it figured out. Parabolas and quadratics starting to make some sense, hopefully. Any questions on 6.4 or 6.5? Remember, you won't make sense of it until you actually do the work, right? Until you go through, kind of struggle through, figuring out what are they trying to ask, what do these words mean. So until you go through and practice on it, it's going to be a struggle. All right, so we've been talking about the parts of a quadratic equation or a quadratic function. We've been talking about, how to find those different parts, right? How to locate the vertex in multiple ways, right? Locate it on a graph, figure it out from an equation, how to find the axis of symmetry or the line of symmetry, how to find the x-intercepts and the y-intercepts. So of all those things, the x-intercepts are the hardest things to find, right? They're the most challenging things to find. Sometimes there could be 2 x-intercepts. Sometimes there's only 1 x-intercept. Sometimes there's no x-intercept. So that's what we're kind of doing, is looking at all the different ways to figure out those x-intercepts as well as that other information. Okay. Every parabola will have a vertex. Every parabola will have an axis of symmetry. Every parabola will have a y-intercept. And those are pretty straightforward things to calculate or to look up. But it's those other properties, those x-intercepts or the zeros or the solutions, right? Those are the harder things to find. So 6.4 was just about finding those, finding them by factoring, finding them by graphing. Yesterday's assignment dealt with some of the special products, so the difference of squares and the perfect square, quadratic, how to identify those and use what we know about those to help us with factoring and finding the zeros, finding the solutions. So today's assignment, there's not a whole lot to it other than a lot of the factoring that we've done so far. It's like we kind of like factor it once and then we're done. But what we really want to be able to do is to factor it completely. And so there's some different techniques for factoring and some different things to look at. So what I thought I would do today is just look at some of the examples in the assignment and work some of those and go through some of the questions that come up about those. And so, and then I'll go ahead and post this video on our website too, under today's 6.6. So, is that all right? All right, so we talked about factoring completely. That just means that we want to factor it, right? So it's all the way factored out. So there's no other things that we can pull out of it. And I'll show you some examples of those here in a second. Zoom in on this a little bit. So it says to factor this completely, and then it's got this, this quadratic here, but it's in this kind of funky form. And what we want to do is we want to look at this and try to figure it out, right? So, so there's a couple things we can do here. Kind of the long way of doing this would be to go ahead and distribute everything, right? And turn it into a regular, ax squared plus bx plus c standard form quadratic, and then factor it from there. And that would certainly work. Like you could definitely do that. But if you look at this, there's some hints in here about how to factor this. Oh, sorry. I thought I was sharing my screen. Thanks, Isabel. There we go. That's better. All right. So if we look at this problem right here, right? So it says to factor it completely. And like I said, we could go ahead and expand that out and simplify it and combine like terms, and then try to factor it. But there's some things that we can see in this that give us some clues and some shortcuts to factoring this. So if I look at this, I notice that I have two things here. I have z times z plus 10, and then I have 8 times z plus 10. And so this is actually already partially factored. So you can see that we have this z plus 10 that's being multiplied by these two things, z plus 10 times z and z plus 10 times 8. So what we're going to do is we're going to factor out this z plus 10. And so the way that we do that is, I'm just going to write it out here, z plus 10. So that's one factor. And then what is z plus 10 multiplied? Well, z plus 10 is multiplied by z, and it's also multiplied here by positive 8. And so I can actually see that factored form right there. See, it has this common factor, this z plus 10. And so I can factor that out. And then the remainder, right, what's left over is the other factor. So I have a z plus 8. That becomes my other factor. So you can verify this if you multiplied this out, right? I could take this z and multiply it by here, z times z, right? And then z times 10, and that's exactly what I do here. I do z times z and z times 10, and then I do 8 times z and 8 times 10. Well, here's 8 times z and 8 times 10, right? So that multiplication is actually the same thing. So this is how I can multiply this out. This is called factoring by grouping. And so what we're doing is we're kind of grouping these things together. I see I have a common factor of x plus 10, so that's one group. And then the other thing that are left over, the z plus 8, that's the other group. The lights turned off. So here's a similar one. I can see that this is going to be, factored grouping again. So if I look, I see I've got a common factor, right? Oops, that's not what I wanted. I see I have this common factor, this 10w plus 1, and then I have this 10w plus 1. And if I think of this as 10w plus 1, but it's 1 times that. And I can kind of see that factoring by grouping again. So here I've got 10w plus 1, 10w plus 1. So that's going to be one of the factors. And then what do I have left over? Well, I have 4w, and then I have 1. So that's going to be my other factor here. It's going to be 4w plus 1. Okay, so again, factoring by grouping. So here's another one that you can do by grouping. So, you know, again, you could just combine this. You could simplify this and say, well, this is x squared plus 11x plus 24. Okay, so that's one way to do that. And then you could just factor that out. You could say, well, I want the factors of 24 that add up to 11, right? And so I can see, well, that's probably going to be 8 and 3. But the other way I can do this is I can do it by grouping. And so I can say, well, here's the one group here, right? And then here's another group right here. And so if I look at this first group, are there any common factors here? Well, there is. I can factor an x out of this common group here, right? This first group. So I can say, well, this is x times x plus 3. Okay, so I can rewrite this first group as x times x plus 3. And then for the second group, I can actually factor an 8 out of this. So I can factor an 8 out of 8x. I can factor an 8 out of 24. And so here I would get 8 times x plus 3. And so I notice here I've got this common factor of x plus 3. And so this becomes x plus 3. And then the other factor there is going to be x plus 8. Okay, so that's another example of factoring by grouping. So like I said, you could actually, do this just in a simpler way or a different way. I could just combine like terms here and I could say, well, this is actually x squared plus 11x plus 24. And then I could just factor that like I would always factor things. So I would say, well, I'm looking for the factors of 24, right, that add up to 11. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And so I can see the factors of 24 that add up to 11 are 3 and 8. And so this would give me x plus 3 and x plus 8. So you get to the same spot, two different approaches to that. So here's another one. I can look at factoring this by grouping. I can say, well, look at this as a group, and I can look at this as a group. And if I look at this first group here, I can see that there's a w squared that's common to those. And so I can write that as w squared times w minus 3. And then for the second one, I can see that they have a 4 in common. And so I could factor this out as 4 times w minus 3. And so I'd say 4 times w minus 3. And there I can see I have that common factor again. And so I can factor this out as w squared plus 4. Notice that this factor is a quadratic, right? We started out the cubic and we factored a quadratic out of it. And then we get w minus 3. Now, when I have this quadratic, w squared plus 4, I want to just kind of double check and see, can I factor this? And so w squared is a perfect square, 4 is a perfect square, but this is a plus here and not a minus. And so it's not a difference of squares, and so I can't actually factor that. So this would be my answer right here. So this one, there's only 3 terms, so I can't really do like factoring by grouping here. I could maybe, rewrite that 12 as something, but for me, that's just a little bit harder. I do see that I have some common factors here. Okay, so I've got an x squared that I can take out of each one of these, and I've also got a 3 that I can take out of those. And so I can do a common factor here, greatest common factor, I get 3x squared. And then what I have left over is x squared minus 4x minus 12. Okay, so that's taking that greatest common factor out of it. But I'm left with this quadratic right here, right, as the second factor. So I want to see if I can factor that as well. And so I want to look at the factors of 12. And I want to see if I can combine those and make a -4. This 12 is negative, so I know that one of these has to be positive and one of them has to be negative. And I want to combine them to make a -4. So I want to find a difference of -4. And so I can see I can make a 4 with a 2 and a 6. So I've got 3x squared. That factor stays there. We don't do anything with that. But the other stuff I can keep factoring. And so I can say, well, this is going to be x minus 6 and x plus 2. Okay, so that's what we mean by factor completely. This means that we want to take each one of these factors and see if we can break it down anymore. This first one would be considered factored, but it's not completely factored. Okay, so if you put this in, it would either mark it wrong or it might give you partial credit, but it's not completely factored, because the second part can be factored some more. Similar thing here, right? I want to see what's a common factor that I can take out, and I can see I've got a 2 goes into each one of those, and an x squared goes into each one of those. So I can factor out a 2x squared. And when I do that, I'm left with x squared plus 2x minus, what is that, 63? So there's my common factor is 2x squared. And so to see if it can be factored more, I want to look at this. And so I'll look at the factors of 63 and see if I can make a 2 out of them. This is negative. So I'm going to have a positive factor and a negative factor. So 1 and 63, 3 and 21. It's 9 and 7. So it looks like with the 9 and the 7, I can make a 2 out of that. This 2 is positive, so I know that the 9 has to be positive and this has to be negative. Okay, so again, that's what we're talking about. We talk about factoring completely, is just make sure that to look at all of the factors and make sure that they can't be factored anymore. This looks like it might be the difference of squares, but 3 is not a perfect square and 147 is not a perfect square. But I can see that 3 goes into both of those. Okay, 3 goes into 147. I know that because 1 plus 4 plus 7 is 12, and 3 goes into 12, so 3 will go into 147. So I know I can take a 3 out of that. And so what am I left with? I'm left with x squared. And then what is that? 3 goes into 147. Goes in, what, 4 times? It's going to be 12. 49 times. So I get x squared minus 49. And now that's a difference of squares, right? 49 is a perfect square. X squared is a perfect square. So this can be written as 3 x plus 7, x minus 7. So again, we want to factor that completely. We want to take out any common factors and then see if there's a way to factor what's left over. Similar thing here, I can take out a 4 and an r, and I think I'll be left with the difference of squares. So that one's just really similar to the previous one. Here's an application problem. So they give you a function, and they say that for modeling the height, right? The height of the debris above the ground. So we can use this function right here. T is the input, which represents seconds. And so they ask you to do 2 things. One, they just ask you to calculate. So they want to know after 4 seconds. And so if I wrote this function out, I could say, height is a function of time is equal to 112 t minus 16 t squared. And then so what they're asking me on that first part A is to calculate what h of 4 is. And so I just have to plug that in and calculate it. So that's pretty straightforward. But the part here that they want us to do is they want us to factor that out. And so if I look at this, right, I can see I've got a common factor in there. So they both have a t in them. And I think that 16, I don't know if 6 to 16 go into 112.
7 times.
7 times? Awesome, thank you. So I can say that this is 16t. And so that would be 7 minus t. So there would be our factored form. These are not a quadratic, right? Those factors aren't quadratic, so I can't factor those anymore. But there's our factored form in that. And then it also tells you down here that these 2 equations are equivalent. So if I plugged in 4 into this and I plugged in 4 into the factored form, I should get the same number. Okay, so that's one of the ways that you can check this. Okay, so this one they're asking you to factor this completely. We look at this, we've got some tricks that we've been using. We've been looking for common factors. We've been trying to look at factoring by grouping. We've tried to see if there's any patterns in there, perfect squares, things like that. And in this one, we don't have any of that. Right, 15 is not a perfect square. There's no common factor. right? 19 is prime, so there's no common factors there. But we still are asked to factor it. So so these are a little trickier, and so I need to factor these out. So what I need to look at is I need to look at the factors of the first part here. So the factors of 15, and then the factors of 6, the very last one here. So that's going to be 1 and 6, and 2 and 3. Okay. And so what we want to look at is we want to look to see if we can find combinations, right, where we multiply the first one by the second one, multiply this one by this one, and then combine those to make a 19. And so that's what we're trying to do here. So if I look at the combinations of these, right, if I said this was x and 15x and 1 and 6 here, what would my middle term be? Would that work out to be a 19? And so if I did 1 times 1, that would give me 1. If I did 15 times 6, that gives me, what, 90? So way off from 19. So that's probably not going to work. If I look at the other combination, if I say 15 and 1 is 15, and then 1 and 6, that gives me 6. So 15 and 6, again, I can't make a 19 out of that. So I know it's probably not 1 and 15. And so if I look at the combinations of 3 and 5, I can say, well, 3 and 5 and 1 and 6, that gives me 3 and 1 gives me 3, 5 and 6 give me 30. So that doesn't work. If I say 3 times 6 is 18, 5 times 1 is 5, that doesn't give me 19. But let's try those with these numbers here. So if I did 3 times 2 would give me 6, and then 5 times 3 would give me 15. Again, that's not 19, so that doesn't work. But if I do 5 times 2, gives me 10, and 3 times 5 gives me 9, that gives me 19. So I know that 3 and 5 are my factors of 15, and 2 and 3 are my factors of 6. And so I'm going to write this as 3x and 5x. Okay. So if I multiply those together, I get 15x squared. And then I want 2 and 3. And I want to put these so that when I multiply 5, I multiply 5 with 2. So if I put a 2 in here, that doesn't work. All right, because those don't get multiplied together. I have to put my 2 right here and put my 3 right here. So this gives me 15x squared. This gives me 10x. This gives me 9x. And then this gives me, so 10x and 9x give me 19x. And then 2 times 3 gives me 6. So that's how that works out. These are the hardest ones to factor, right? There's just so many different like cases you have to look at and combinations of things you need to do. There is a method. It's kind of just like this algorithm, a set of steps that you can go through to actually figure out what those numbers are exactly. But it's a little convoluted, and there's a lot of steps. I'll post the video of it. It's at the end of one of the Nancy Pie videos where she talks about factoring, and she calls it this X method. And so I'll repost that video, and you can take a look at that if you want to. Okay, so these are the ones that typically give people the most problems when this leading coefficient here, right? This A value is not 1. Then it's a little trickier to do. So a similar one here. I'm going to look to see if there's a common factor. There's not, right? 13's not, 13 is a prime number. So, and I can't take the factors of 3 and the factors of 12. I don't think. Let's see if we can do that. But it's not a perfect square, right? And there's no common factor. So we're just going to try to factor this out. So I have 12w squared minus 13w plus 3. I'm trying to put it in this format. So I want to look at the factors of 12, which are 1 and 12, 2 and 6, and 3 and 4. Then I want to look at the factors of 3, which are just 1 and 3. So that's a lot easier. And this is positive, but this is negative. So that tells me that both of these numbers have to be negative. So the factors of positive 3 in this case are going to be -1 and -3. So now I've just got to go through and find combinations, right, that will give me -13. And so let's see if I can do that. I'm going to start down here at the bottom. So I'm going to look at 3 and 4. So I can do 3 with -1 and 4 with -3. So that could be -3 and then -12. So that doesn't quite get me there. Let's look at the other combination there. So if I look at 3 times -3, that gives me -9. And 4 times -1 gives me -4. There's my -13. Okay, so I'm going to use 3 and 4 and -1 and -3. So my factors here are going to be 3w and 4w. So that gives me the 12w. And then I'm going to have -1 and -3. But I want to make sure that I'm going to multiply this 3 times -3. So if I put a -3 inside here with the 3, they won't get multiplied together. So that -3 has to be down here. And so I get 12w squared. I get -9w plus -4w. That's -13w. And then -1 times -3 gives me +3. So again, these take a little more time to kind of go through and look at, all the possibilities. What could it be? Same sort of thing here. Looking at the factors of 3, looking at the factors of 2. There's 3 is prime and 2 is prime, so there's not a whole lot of combinations here. But so you still have to kind of go through and look at the combinations. I notice that this 7 is negative, so that means that the factors of 2 are going to be negative, -1 and -2. So try to make a -7 there. So take a look at that. Same thing here, factors of 25, the factors of -12. Try to find some combination that add up to be +20. And this -12 here means that one number is negative and one number is positive. So '14 is a similar thing, is factoring. Look at the factors of 3 and look at the factors of -14 and see if you can find some combination that you can build a -19 out of. Same thing here. Here. Okay. And the very last one, there's a common factor in there. So can factor that out and see if that helps you. But then you'll have to factor the rest of it. So I think you can take a 4 out of each of those. Can take a 16 doesn't work. I think 4 is the biggest number you can take out of there. Yeah, so that's really all there is. We're just looking at some different tricks to factoring, and looking at these quadratics where that leading coefficient is not 1, and trying to figure out how to factor that. So it takes some practice, right? Watch the videos. I'll post the video to Nancy Pye where she talks about the X method of doing that. You might try that and see if that makes sense to you, or if you can, figure out those steps. It's not hard to do, but it is, there's a process that you have to work through, and it'll tell you those answers. But you gotta memorize that process. Every time I think I have that process memorized, I go away from it for a little while, and then I come back and I can never remember what those steps are. So I'm constantly having to relearn that, and I don't do it very well. So, but take a look at it and see if that helps you. So we've got about 20 minutes left. Are there any questions about anything that you want to talk about? Any questions on 6.4, 6.5, 6.6? Okay, so I'm going to go ahead and stop the recording of this right now. And I'll post the recording of this up on the website.